Sampling is the process of selecting a portion of a population to represent the whole population in statistical analysis. It is used to collect data from a large population in an efficient and cost-effective manner without having to study the entire population. Some of the key considerations during this process include sample size and representativeness. Sampling process is of two types: probability sampling and non-probability sampling, which we will now discuss. Probability sampling is a method where each unit in the population has a known and non-zero chance of being selected. This method is suitable for inferential statistics and hypothesis testing, and its results are representative of the populations and unbiased. It is easy to analyze and generalize, but this method has certain disadvantages. It is time-consuming and complex and requires a complete list of the population. Some of its examples include simple random sampling, systematic sampling, stratified sampling, cluster sampling, etc. Now we have non-probability sampling, a method of sampling where the chance of a unit being selected cannot be accurately determined. Its use is limited to inferential statistics and is often used in exploratory research. This method is quick, easy to conduct, flexible, and suitable for hard-to-reach populations. But the results derived from this method may be biased, not representative of the population, and difficult to generalize. Some of its examples include for convenience sampling, quota sampling, snowball sampling, judgment sampling, among others. Something called the sampling and non-sampling error. A sampling error occurs when a researcher chooses a sample which is not representative of the population. On the other hand, non-sampling error refers to errors other than the sampling, such as error in the estimation. There are ways to mitigate such sampling errors, which include analyzing the sample in the planning phase, execution phase, as well as the analysis phase. Sometimes, despite adopting all these steps, it is difficult for researchers to remove sampling bias, which occurs when some members of a population are systematically more likely to be selected in a sample than others. For example, to analyze the voting patterns for presidential elections, if you poll 1,000 middle-class, blue-collar voters, the sample will be heavily biased because it won't be diverse enough to paint the whole picture.